Hello everyone. Today we are going to solve the problem search array with adjacent difference at most k. So it is a difficult easy question. So given a step array ARR. So its step value is k and a key value x. So we need to find the index of key x in the array. If multiple occurrences of x exist, return the first occurrence of key. In case of no occurrence of x exists, then return -1. Note, a step array is an array of integers where the differences between adjacent elements is at most k. So for example, array is equals to 4, 6, 7, 9 and k is equals to 2 is a step array as the difference between the adjacent elements in the array is at most 2. So not more than that. So there is some sample input and output and the expected time and space complexities. So let us first understand with the sample input. So we take the first one, which is 4, 5, 6, 7, 4, 5, 6, 7, 6 and the x value is equals to 6 and k value is equals to 1. So let us know. So we will be solving. So they gave that we can also solve in big O of n. So we can just use a linear search and implement this program, which is the most basic way. But we are going to optimize a little bit the linear search. So in that way, that this type of problems come under the optimization of linear search in the given conditions of array. So the given condition by them is the step array, in which the adjacent element differences is at most k. The k value is given by them. So we will be using this k value as a formula to design and optimize the linear search. So our strategy is, so the first step, which is we will iterate the whole array while our I value is less than the size of array, and our formula is, which we are going to use, the next possible value at where the element x can be present in the array is I plus max of 1 comma array of I minus x by k. So this is the formula we are going to use. So let's see how this formula works. So now in this case I is equals to 0. So at this one the value is 4. So we didn't find the x value. So we will be calculating the jump value. So jump is equals to array of I, which is 4 minus x, which is 6. Its mod value whole divided by k value. So 4 minus 6 is minus 2, but mod is 2 by 1 equals to 2. So jump is equals to 2. So now we said that max of 1 comma max. So max of 1 comma 2, which is 2. Therefore I is equals to, I was 0 plus 2 equal to 2. So we didn't just increment the I value by 1. We calculated using a simple formula and then we updated the I value such that the searching strategy is optimized. So in the second step, I is equals to 2, which is 6. So it is equals to x. Therefore return the index. Therefore output is equals to 2. So like that, very simple question. So we just need to optimize the linear search algorithm, which is the most basic one, to some extent, based on the given array's condition or the type of array. So now let's just convert that logic into the program. So while, so first we will initialize the I starts from the 0, and while I is less than length of array. So we will, if our current I value is already equal to the X value, then simply return the I value. So one case is over. So if it is not equal to, then it will come to else case. Then we need to perform the first calculate the jump value, which is mat.abs of array of 5 minus x, this value divided by k. So after this, we will initialize the I is equals to I plus max of 1 comma jump. So at last, if we didn't find the value, then -1 is the output, as they said. So the sample test case is passed. So the hidden test cases are executing. So this program is, as we know, basically just optimizing the linear search. So we can see all the test cases are passed. So now we will analyze the time and space complexity. Although we don't have any particular complexity, in the worst case it can go up to n. But in the most of the cases it will not go into up to n, but rather than less than n. But we cannot say any particularity in the time complexity. So we just consider the worst case, but it is the optimized one. So time will be n, space will be 1. So if you compare, they are matching. So in this way, you can solve this program using the optimized approach. So kindly go and practice this program. The program link is given in the description. Thank you for watching. Subscribe for more videos.